Today I want to show you my favorite backup tool right now. It doesn't just help you with Zammad, but also with other tools and systems in general. You can adapt the shown comments to any of your projects. Restic is a very lightweight, deduplicating and thus fast tool. It uses AES 256 encryption by default and supports a great number of backends. These are S3, SFTP, regular directories like SMB or NFS shares, Restic REST server, Microsoft Azure Blob Storage, Google Cloud Storage, OpenStack Swift and rclone. I implemented this for Zammad back in my days because we had to touch the backup process anyway. This allowed to reduce the complexity of the backup, restore and migration process. It handled big data extraordinarily well. Seeking through a directory for changes in a 5 TB service with many small files took roughly 90 minutes on NVMe only. I will use S3 as storage in this video. The general comments are the same in between the backend storages. Some options may differ slightly. The detailed Restic documentation will have you covered in those cases. My point of view will be a rather automated approach for the use in scripts, for example. I will also go for a per-service backup and thus ignore hosts entirely. I will point out that specifically where it matters. Let's take a look, shall we? First of all, we have to install the Restic binary, of course. The package is available in the majority of the repositories of many popular operating systems already. If your operating system is not covered, you can also retrieve the binary from the GitHub repository. As usual, I'll be using a Debian system here. My experience with the Debian version is that it is slightly outdated. To fix that, we will execute a simple Restic self-update after the installation. A side note on the package version. If you're managing updates via, for example, Ansible, you will have to invoke the Restic self-update after updating your packages. Restic uses so-called repositories for its backups. These repositories are version specific. Ask me how I know. Next, you will need to create a S3 bucket with independent credentials. In my case, I'm using a Menu installation. As the web interface no longer supports proper management, I will use the Menu console. If you're just backing up locally, that would be a fitting folder visually. While Restic does come with support for several hosts in the same backup directory, I personally prefer dividing it at least on a host level. If you want to divide it even further, you can also do that on a customer or service level. Back when I implemented this at Zammad, I chose the per-service approach. This comes with great overhead in terms of managing all the credentials, but strictly fences data of each service. It also slightly increases the security in my opinion. For the simplicity during this video, I will use the following environment variables in the user I am using. AWS access key ID as the S3 username, AWS secret access key as the password of the S3 user, and Restic password as the password for the repository which Restic will use for the encryption. I will also use the root user to do this. While this works, using administrative users is not always the best idea. You may have a much safer approach to tackle this. Please feel very welcome to share those in the comments or just use them. Before we can actually use Restic to backup, we will have to initialize the backup repository once. It will set up all required data in the backup directory and generate the signing and encryption keys. Personally, I like to use some further settings flags I consider useful. Again, these are mostly relevant for scripting. With --JSON, Restic will no longer return the current state, but provide the JSON after finishing the operation. This is especially useful if you want to check returns in a script and need a standardized way to note down information. With --cachedr, you can tell Restic to use a different path for its caching directory. By default, Restic writes a .cache/restic directory to the executing user's home directory. If you're using, for example, mounts on the home directory, this might be troublesome for you. You can also disable the use of caching directories entirely with --no-cache. This will slow down most of the processes, as Restic will have to retrieve all repository information needed for the operation in question. In my personal experience, the cache directory will require roughly 40 GB of space per 1 TB to backup. Your experience might vary. With --quite you can omit any additional program output except for the JSON output. While I'm omitting the JSON and thus also the quite option, I would usually use them for scripting. Now we have everything we need for our first backup. Now, general backing up of data directories is no problem at all. However, when it comes to things like databases, you might want to consider some things. I prefer to write the database dump to the file system before running the backup on the data directory. This way you will have one snapshot for your database and data directories. Also, while Restic does support backing up data from standard in, it's dangerous as Restic can't know if the data is incomplete or not. The size of your database dump is also no problem as long as you're not storing binary data in it like attachments. To save time, I wouldn't even bother to compress the dump and just remove it after Restic backed up the data. Before executing the actual backup, I prefer to instruct Restic to try a repository upgrade. This is in case the Restic version changed in between two backups. Certain functions are not available to all repository versions and the execution takes virtually no time. It's not a hard requirement though. Now let's take the Zammad installation as an example. We will want to backup the whole opt_zammad directory, excluding the tmp directory of course. I dumped the PostgreSQL database to tmp zammad psql beforehand. Ideally this would happen in a script and thus would reduce the data drift between database and file system. Let's break down the comment. --no_scan disables Restic scanning for the size of the directory it's going to backup. This also disables the ETA estimation for the process. It basically improves backing up even more. --read concurrency defines how many threads Restic will use to read in parallel. Back in my Zammad days I found that 25 is good value for NVMe based storages. For slower storages like good old rusty drives, you might want to lower the setting to 10. You might have to fiddle around a little, I'm just guessing a fitting number here. --pack size defines the size of each independent pack. 128 stands for 128 MB and is currently the maximum supported. Restic will write 128 MB chunks and uploads it when the limit has been reached. This setting also depends on your backup storage. Keep in mind that this will require additional storage temporarily. With a read concurrency of 25, you require up to 3.2 GB. I also prefer to disable compression with --, compression off, simply to burden the CPU as little as possible. The network interface on the other hand will be on fire. -r tells Restic what repository to use. If you're not using S3 in your case, you would simply provide a path to the backup repository here. With --exclude you can exclude certain directories. Now as you can see, my fairly small instance was backed up in no time. There are even more options like taking backups or ignoring empty snapshots. I consider these fairly advanced and want to keep this video short and simple. I don't consider these things as relevant for automated processes. Restic backup directories don't need that much of love. There are things that may be important though, so I'll mention them for the whole image. Every time you invoke a backup command in Restic, this will create a new snapshot. Officially, the most relevant comment is listing your available snapshots. As you can see, Restic tells you about the snapshot ID, creation date, affected hostname, text, directories and the size. The most important information in this listing, at least in my opinion, is the date, directories and of course ID. During a restoration you will need said ID unless you're planning to restore the latest version of your backup. Of course, Restic also allows you to search for specific directories or files. I prefer adding --long to the listing, because it will also show you when the file or directory was last updated. You can use any snapshot version as you please. Technically, you can also mount your backup repository to transfer single files or search easier through all snapshots. This requires your kernel to support Fuse and is also slower than the actual restore command I'll be showing you later. Restic just adds endless snapshots to your repository, unless you tell it to throw away data explicitly. This is usually a two-phased command. However, I prefer to execute it in a single one. This cleanup process can take quite some time and might be a burden to your backup infrastructure. Back in my Zammad days, I had to execute this operation during daytime, because the backup host used rusty hard drives only, which couldn't keep up writing and reading with active backups on top. The backup window was much more important than throwing away snapshots after. At least that's my point of view. Your infrastructure might be better in that regard, of course. The --- group by setting allows you to ignore the hostname during the snapshot prune. Otherwise, Restic would apply your keep configuration on a per host basis. If you are backing up per service like I do, this would be a problem if you're juggling the service around your infrastructure. With --keep hourly 1, I instruct Restic to remove all hourly snapshots but the latest one. It will take an account each day independently. You definitely want to raise this number if you back up your stuff several times per day. I'm keeping snapshots worth of 14 days with -- keep daily 14. To set the snapshot policy and throw away snapshots at the same time, I'm using -- prone. This will go through all snapshots and reconsolidate packs where needed on the fly. This is also the reason why this process might cause some burden on your backup system. Storages may fail over time. This doesn't just affect your backup system, but also your productive system. It is crucial to ensure that your backup is consistent. This is usually done with regular test restores, but let's be real, many of us skip these. The least you can and should do is to at least let Restic check the repository data regularly. Depending on the size of your backup, you might want to use -- read data subset to define only a portion of your backup to be checked. There are several ways to do it. I prefer a percentage on that regard. In my example, Restic will read 25% of your backup randomly and ensure that the data is consistent. If it is not, you hopefully notice before you actually need a restore. If you just use the check command, the whole repository will be read. Repository keys are basically the Restic password. You can have several keys for one repository, which makes a lot of sense if you're backing up several hosts to the same repository. Should you ever need to change the password of your backup repository, you can do so at any time. Restic will always change the password of the current provided password. When adding another key, you will be prompted for the key's password. Of course, you can also remove a key. For that you need to list the relevant keys before. Pick the relevant ID and then remove it. In rare cases, your backup repository might be locked. Restic locks its repository doing any operation it does to detect if the repository is in use already. This also means that you cannot back up two services or hosts to the same repository at a time. You have to unlock the repository if a process of Restic died and couldn't remove the lock anymore. Be aware that this is a dangerous operation if the repository is still in use. Before I nuke the Zammad installation for restoration, one important remark. Restic by default backs up file and folder attributes. This doesn't just affect the permissions, but also the owner and group. It does so by using the user and group ID. In this case, an Ansible script that uses specified user and group IDs will be a huge plus, unless you want to execute a recursive change owner on the restored directories. This won't be a problem until you have many little files at hand.
Oh no!
I accidentally recursively removed my Zammad directory and dropped its database. I would never do that mistake, right? In my example, I will restore the latest available snapshot. However, if you need to restore a different version, just replace latest with the snapshot ID in question. A very convenient option Restic offers is to dump data to standard out during the restoration. We will use this approach for restoring the database. This will save precious time during a restore. All we have to do is to provide the dump file we've backed up. Restic will only restore the provided file. I'm directly piping the dump's content against PostgreSQL for the Zammad database of my installation. Now all that is left is to restore the Zammad directory. -- include helps me to control what Restic is going to restore. I just want the Zammad directory back, but not the database dump. By using --target/, Restic will restore to the original directory it read from. This is ideal for a disaster recovery like I just made necessary. As Restic overrides any file in the destination that is available in the backup by default, you might want to write to a different target in some situations. You can also control this behavior with a -- override flag if needed. With --delete you can optionally also instruct Restic to delete everything in the destination that is not inside your backup. After the restore process finished, you might have to adjust the folder permissions. Also, your database credentials might be off in regard to what Zammad expects. When these two things have been addressed, Zammad should be back in working condition. As you've managed to watch until this point, I'll give you a little goodie. Use these QR codes to receive a backup and restore script for Zammad and paperless Nginx. It's inspired from the original Zammad backup and restore. You can adapt these further if needed. What's your opinion on Restic? Let me know in the comments. Until next time, take care.